All right, let's work on finding some limits. So the first thing we want to do is always see, does a limit actually exist at what we're trying to approach. So here we're trying to approach x equals 2. So if I do that limit, we would have 3 times 2 minus 4 over 2 times 2 plus 5. 6 minus 4 is 2. 4 plus 5 is 9. So the limit of this as it approaches 2 is 2 ninths. That exists. We can move on. Nothing major we have to do here. Whereas the next one, if we're approaching as x approaches infinity, we get e to the infinity over 3 to the infinity, which is a positive infinity over a positive infinity. That tells us we should check it with L'Hopital's rule. So we want to look at the first derivative of each of these. So now we have the limit as x approaches infinity. Well, the derivative of e to the x is e to the x. The derivative of 3x is 3. Now when we take and approach our limit, we get infinity over 3. And we know from our other rules that that means that the limit of this is positive infinity. All right, now what happens with this one? Here we have, we're approaching x approaching 1/2. We're got the natural log of 2x over 4x squared minus 1. So let's just see what happens first. So the natural log, 2 times 1/2 is 1. And then here we have 4 times 1/4 minus 1. We end up with 0 over 0. Again, we don't want to work with 0 over 0, so we're going to check L'Hopital's rule. So let's take our derivative of each of these functions. So we're going to, So we have the limit as x approaches 1/2. So the natural log of 2x, that would be 2 times 1 over 2x. That would be its derivative. And then 4x squared would be 8x. So if I plug in 1/2, I'm going to end up with 2 times 1 over 1, and then 2 times 1/2, or 8 times 1/2 is 4. So the limit as x approaches 1/2 is 1/2 for this expression. All right, so now let's go to our final one here, where we have the cosine of 3x over 2x minus, or 2x over pi minus 1. So first thing, cosine of 3x as x approaches pi over 2, this would be the cosine of 3 pi over 2, and then this would be 2 times pi over 2 over pi minus 1. So here I end up with cosine of 3 pi over 2 is 0. 2 times pi over 2 gives me pi. Pi over pi is 1. 1 minus 1 is 0. Again, 0 over 0 tells me I need to check L'Hopital's rule. So we need to take the derivative of each of these. So I'm looking at the limit as x approaches pi over 2. Well, the cosine of 3x, its derivative, would become negative 3 sine of 3x, because derivative of cosine is negative sine, and the derivative of 3x is 3. And then if I take 2x, 2 over pi x, I know that this would give me 2 over pi as my derivative of my denominator here. Now I can plug in pi over 2, and I have negative 3 sine of 3 pi over 2 over 2 over pi. So now when I look at that, I end up with negative 3 times, well, 3 pi over 2 puts me down between the third and fourth quadrants, so this is negative 1. And then I'm going to say that this is multiplying by the reciprocal, which is pi over 2. So what this means is that the limit is 3 pi over 2.